Hello and welcome. Thanks for joining our webinar today on hybrid mobile for Hexiwear. Hexiwear makes it easy from an embedded hardware and software perspective to develop IoT and wearable products. Evothings is here to make it easy for you to create mobile apps that work with Hexiwear. So I'm excited to announce our presenter today, Dr. Alex Johnson, co-founder and CTO of Evothings. He'll take over in just a moment. So please feel free to type in questions for Alex as you follow along. We'll spend the last 15 minutes of this call answering your questions. I'm your organizer, Roshnika Fernando from NXP. This webinar is recorded so you can share and watch it again at Hackster.io's contest page for Hexiwear. So with that, Alex, let me hand it off to you.
Thank you so much, and thank you all of you out there for attending this webinar. I will take you through the agenda, and this is a picture of me because these webinars have the downfall that you can't see each other, but this is pretty much what I look like. It's my daughter took that picture, so it's a bit from underneath. So what I would like to talk to you today is first start off, because I'm an old academic, with the hybrid mobile development big picture and why this is interesting, and some of the ideas and concepts surrounding it. And then I'll take you into the open source software that I've been involved with the last 3 years, the Evothings Studio, which is released on the Apache license, and a possibility for people with web skills and general developers to clients, not only people with specifics in iOS and Android development, but for a larger audience. Then we'll step into sensors and hardware, and specifically the Hexiwear, naturally, because this is about the Hexiwear and that all-in-one device. And I'll take you through some of the code, and some people may find code walkthrough painful, so I've taken some highlights, and in the handouts and also towards the end there will be links where you can get all the proper software that will then actually work together with the Hexiwear, with some examples, so you don't need to jot any of the code down. It's more that I want to explain some of the main concepts involved. And just like Roshinka said, towards the end we'll have a Q&A session, so please write down questions and we'll queue them up and do our best to answer them. So starting off with hybrid mobile development, and the background is that we see that the mobile devices have, from just being a peephole into the cloud, being able to see some graphs on a small web page, they've taken on more roles, and the CPUs and the capacity of RAM and storage, battery life, etc. has improved to the point where the mobile can have so many more roles in the system. Sometimes the mobile is the sensor, and the more part of the companies selling sensors today, they usually wind up in mobile devices. IoT sensors is maybe a few percent of this market. So phones is huge, and many of the sensors on board are quite powerful. You can also use the phone for visualization of data, of course, and just as often the phone is acting as a remote control. It can act as storage, especially when you're offline somewhere where you can't access the cloud continuously. Then you can store data offline, and then the moment you get network coverage again, that data can be quickly uploaded. So you can use the phone as a cache for local data. And of course, a lot of the crunching can take place, so you can have several data sources, and they gather up on the phone, and you can compare, for instance, real-time data with historic data. So we see this as some kind of IoT stack, starting off with the user and his or her APIs, UI things, cloud, down to the bare metal and the sensors. And in all of this, the phone will have new roles, and it's important also to have tools to cover for this. So these are some of the key points that often as a user interface, but sometimes also part of the infrastructure. For instance, if you have a wearable device or a device like the Hexiwear, one of the ways of getting data out is to use Bluetooth Low Energy. And then the phone will be a gateway for these local devices. And you can also serve as an integration platform where you get some data from the cloud and you can compare it with local data. And of course the computing capacity it has. And in terms of development, if we look at which way to go, it's often been a choice between doing native development and using Google's and Apple's tools to create applications that are bespoke for each operating system. The other end of the rope is the HTML, and where you actually use the web browser's capabilities. But as we know, there's a lot of limitations what you can access from within a web browser. And secondly, web browsers on mobile devices are also can be very different from one another. So it's a very heterogeneous environment where a Chrome browser on an iOS device and if you get a Firefox device from another manufacturer, then they can behave very differently even if the code is the same. So a lot of the issues that were around and are partially fixed with HTML5, they come up again. So there's a third option. This is to do hybrid development. It means that some of the functionality is in the native part of the application, but then you use a special UI element called a web container, and some of the code and some of the logic can run inside of that. And this is very interesting because it means that you can load some of the code when the app starts or on demand, and you can give it new functions without needing to compile the code once again, sign it, put it on the App Store, possibly waiting 2 or 5 days, etc. And we see several of the big players that do mobile device management, they also utilize this. And it's quite straightforward, and it's easy to create a gateway between what's going on inside the web container and outside. So I'm going to talk about this third kind, and this is the picture of the liger. It's a lion, tiger, and in a way hybrid is the same then, that you can make native parts, and these are often created in beforehand, and you make them using the traditional tools programmed in C, variations thereof, or Java. And this is usually presented as so-called plugins, and you have a plugin would be specifically covering one function. So you have a plugin for storage, you have a plugin for Bluetooth Low Energy, you have a plugin for RFID reading, you have small plugins. Maybe one plugin is just doing the vibration and nothing else. And this is a way of having a abstraction layer on top where you can write a single code, piece of code, often in JavaScript, and then different things happen under the hood depending on what system is present. And once you're finished, you sign these applications with Apple's and Google's tools, and then you can publish them on app stores just like any other app. They're just made in a different way. And already today there's several hybrid tool sets on the market, and many of the big players are using this, and they often come from this Apache Cordova framework, which is kind of a vanilla system that caters for the bridge between the web container and what goes on around. And Evothings Studio is one of these, and Salesforce has one, Intel, IBM, Adobe, etc. And what is special with the way that we've chosen, because these are of course interchangeable, is that we looked a lot at what's going on inside the Internet of Things, and we looked at messaging protocols, we looked at important APIs, important cloud services, and of course important ways of communicating with devices, both embedded and wearables, etc. And we made a version of this tool which is bespoke for this industry. This is a comparison between how apps are developed, and this is in the handout, so you can actually look at this later. What we have under the hood is the process where you write in JavaScript and HTML. It lands in the web browser control, and from there's a native command that goes down into the underbelly of the app, and you get a callback. And this can contain either just singular data or strings, but it can also contain arrays of data or binaries, etc. So there's an interplay between the browser and the native part. And using these so-called plugins, one for, for instance, we talk about Bluetooth Low Energy, we have a plugin for iOS, we have one plugin for Android, and also plugins for Windows Phone and other operating systems, but those are maybe the three most important. So every time you have a function you want to see on the native side, you have to build once for every platform, but then again only once. So that means that you can reuse them. And there are several sites on the net where you can pick up these, and they are rated, and you can see their popularity, etc. So I would say that Evothings Studio is a bit like a duck then. Sorry, I'll have to close the door. Sorry. I'm sorry for this interruption. So you have JavaScript libraries and functions on top, and they're supposed to be very easy to use and common to all the target environments. And then you have the native libraries underneath. So for Evothings Studio, we have three parts really, where we want to access the cloud platforms, connect to those. We also want to see industrial hardware and different devices that are important, key devices for this industry, and also various kinds of connectivity. And the end goal for us is to have rapid processes for the entire app lifecycle, both during development, but also when it comes to distribution, and if you want to, over time, update the functionality of an application, or you want to create, you want to localize languages or different SKUs for various purposes. Maybe you have a lot of brands that you want to have a similar application. Then it's very easy to have a common code that would work for across the devices, and then you can add and skin it just like you would with a web page or a website. And what we also offer is the possibility of using web technologies and these prefabricated components for key technologies such as Bluetooth Low Energy, for instance. And we've chosen to open source everything under the Apache license. It makes it so much easier also, both for the maker community, but also for companies. One of the important features that you get with having web technology is that you can have an instant update, that you can have the source code, and for a web developer this is quite normal. You write source code, you press save, you go to the browser and you press reload. But for a mobile developer the process is more cumbersome. It involves building the application, you need to sign it, you need to put it somewhere or use some pre-flighting software. So here we can have the very quick turnaround of web technologies. And we've chosen to do this by having a client that's available in the App Store. It's the Evothings viewer, and it's packed with these native functions. So there's hundreds of native functions, and you can access them all by invoking a JavaScript code. So you can have a generic client. You can say it's half an app. It's the native part of an app. And then in runtime you can download web part or the JavaScript part and have it run. And this is very convenient both for development and testing and also field trials where customers can use this in the field. And you can access all the goodies of the web technology. So there's a lot of UI frameworks out there like React, Ionic, Sencha, etc. And because it's basically web technologies, so all of these client-side UI libraries you can use in your own application. And we have quite some examples with many of these frameworks, so it's easy to get started. Okay, that was the Evothings part. I hope it wasn't too markety, but there's a second part here, which is about more on sensors and hardware and the Hexiwear. And these are some of our own findings, but also some of the voices we've seen on the net. And one of the things that is interesting with the Hexiwear is that it's fairly user-friendly in the sense that it has a good form factor. It has this 96 times 96 pixel screen, which allows you to see what's on there. And I have some other devices here on the slide, and they're all good. They've been around for some of them, like the TI sensor tag has been around for a couple of years, and they don't work as well standalone. And especially if you're a maker or you're working in the development or proof of concept phase, it's nice to see what's going on the device and if there's actually data there, and then you have something connected to it, a computer, a phone, etc., and you can see the data flowing and you can do comparisons. So it's also very nice for debugging. And there's some trends here we see, both that a lot of hobbyists are starting to use the devices, but they're also taking them to work. They're also people that are weekend warriors with sensor equipment, but they also use them in the professional life. So we can see different verticals, and it can, for instance, be I've seen there's a big system up with Bosch where they have these big generators they sell for hundreds of thousands of dollars, and then instead of exchanging it for a new one, they retrofit it with these sensors and modernize the equipment that the customer already has. So this is a very efficient strategy actually to retrofit the equipment already. And we see also that Bluetooth Low Energy has become a key for all these devices, since it doesn't drain the battery so quickly, and it's also easy to use so for the rapid development. And with BLE, for instance, there's limited need for the infrastructure because you don't need a network. Phones and tablets have these things built in, and the cost is much lower. So we think that there's all the prerequisites in place, and the Hexiwear is no exception because it has a lot of sensors on board. We also see that there are new kinds of developers coming in. There's web developers, makers, embedded people that are very good with soldering iron and hardware. We have a lot of people using ARM embed, for instance, who haven't had the skill sets for creating mobile services and applications, but using these highly abstracted systems, it's easier for them to create the end-to-end solution, and it makes their hardware more interesting because instead of having the hardware on the table, you can actually see data flowing out, and you can do more of these things in-house, and you don't need to hire third parties to the same extent that you make a specification for what the app is supposed to do, and then you wait 3 weeks and you get the app back, and it's almost there, and you do a new iteration and a second one. If you have these web technologies, you can do a lot of the connectivity natively, and there's sort of finalized components for this, and then you can add the logics and UI, and you can do quick iterations this way. So this is the Hexiwear inside. There's been quite some really nice webinars in this series before covering the Hexiwear, so I'm just have a few slides on this. And we see here the Kinetics K60, the ARM-M4 microprocessor in the middle, and to the left of it there's the RGB LED that you can control, and then some of the sensors for pressure, humidity, the ambient light, the connector for the touch sensor, for the capacitor, the 6 capacitive buttons, and the battery connector. And then on the other side you see the hook for the docking station. There's a small antenna, and next to it is the KW40, which is the M0 that runs the BLE part. The big round thing is the vibration motor. There's a heart rate monitor which has 2 LEDs of different wavelength that allows you to see the heart pumping either for your fingertip or your wrist. There's a big reset button. I used it quite a lot in the beginning, but now with the latest firmware version I'm not pressing the reset button, but I know where it is. There's also an accelerometer, magnetometer, the gyro, and the USB connector. So there's plenty of sensors in here. So it's a very nice device to do prototyping with. And then if we look at the Evothings setup, you can see trying to cover all the parts here. There's a cloud, which is the Evothings. It's a mirror. So there's a mirror in the cloud, and basically you download the PC or Mac Linux software, which is called the Workbench, and you write code there. And every time you save, the local version on your desktop or laptop is mirrored to this cloud server. The cloud server then is catering for connecting to mobile devices, and you can connect one or several mobile devices at the same time. So you can see the code running on an iOS device and an Android device and tablets and phones at the same time. So you can see the code running on different platforms. And the system has this zero turnaround effect. So what's happening here with the Hexiwear device is basically that the phone and the Hexiwear device are speaking to one another over BLE, and the computer is not involved in this process. The computer is just serving the code source for the phone. And when an update is received, when you press save in your text editor, basically what happens is it pulls down the BLE radio. It reloads the code inside the web container, and then it turns the BLE radio up again. So there's a lot of things happening under the hood, and the effect is that the app is actually reloading in real time. And what you see here is one of the 2 examples I have published together with Andreas on Hackster. This is the accelerometer. So we're reading the acceleration data in 3 dimensions of the Hexiwear device, and you just put it into sensor tag mode, and then data will flow, and you turn the Bluetooth on naturally, and then we're drawing on a canvas element. So it's a quite simple example, but you can see all the steps involved in connecting a phone to the Hexiwear device. So, and basically Evothings projects, they're Apache Cordova projects. So if you're a web developer or know how to make web pages, you'll feel quite at home here. There's index HTML file. So if we look at the window on the right there's an index HTML file, and there's an app.js. That's pretty much where the action is going on. And then you have one folder with libraries. Some of them are UI libraries. One of them is carrying the UI, the CSS, the fonts, images, and things. And then there's an app icon, and that's the icon you actually see in the workbench. And there's a small JSON file that handles some of the descriptions, names, versioning. And the clip to the left is basically the inside the index HTML. This is the roster of scripts. So this is the index HTML is kind of the octopus, the file that holds everything in this folder together. And the good thing is you can take something from another, for instance, there's an Apache Cordova. The commercial version of it is called PhoneGap. You can actually take a PhoneGap project and you can pull it in and drop it in Evothings Studio. You can also take software examples that we have written and run it in another environment. So there's very little lock-in here, and we across even though we're often competitors across the borders, we help each other and we publish each other's plugins. So it's pretty open source-ish. So I'd like to spend a few minutes on EasyBLE. This is one of the helper libraries, because we have this native part, the BLE plugin, and there's one for iOS and one for Android. The Windows Phone one is a bit grayed out, and it's not up to speed with the others, and there's not as many requests for us, so that we're focusing on the other two. And then on top there's an abstraction layer that we call EasyBLE, and I will show you a bit the basic functionality there. First of all, you add a script tag, in this case EasyBLE.js, and it allows you to do things. So then you would call them using evothings.ble and then different functions. So these are some of the main functions here. We have a connect function. It has the device. It has this callback that I mentioned, and also if you fail, you have a connect error. And basically what you do here is you read all of the services in one go, because it's an efficient way to do it, and you store it inside an object for reading all the data. So the BLE world has a device. The device has services, and then these services in turn, they have characteristics and descriptors. So you have a service for accelerometer, and then you have its characteristics, the X, Y, and Z, and sometimes there's also descriptors and ways of converting these data. Usually it's a value between 0 and 255 or similar, and then you need to convert it into a meter per second square, etc. So this is how we get the services and characteristics out of there. Each service has an ID. It's called a UUID, which is unique for that service, and then each service also has these characteristics, and they also have UUID. So when you're calling this is a recursive. So first you call a list of all the services, and then you go through it and call all the IDs. And this is the same regardless if you have an iOS device or if you have an Android device. It would basically play out the same way. So for a developer, it's nice, because if suddenly the BLE the functions for core Bluetooth, for instance, which is the main function to access on iOS, is changed, this code will still be valid. So we're not future-proofing everything, but there's a highly good percentage that it would work. And then finally, these are the workhorses that we do a lot of read and writes. We write the characteristic, and you can see we have a handle for the data. We have one handle for the device. So a certain device, the Hexiwear, we write to, for instance, interval we want to update, and then the actual data, and then we have a callback if it was successful, and an error. And the same thing for reading. And then thirdly, to enable notifications. And this means either you read a value, you read it once, but you can also enable notification for that value, and it means that you will continuously get data from a sensor, for instance. And every time the sensor value will change, you will get a callback, and this callback you can act upon. That's exactly how this accelerometer example works. So taking you back to the studio, it has a number of tabs. The first one is the Connect tab, and first time you install, you get a cloud token, and this is unique for, it's an anonymous token. It's not connected to anything at first. You can personalize it and connect it to yourself, so you don't need to log in. You can also have several cloud tokens connected to an account, but they start out like this, and it allows you to see what mobile devices are connected to what workbench. Once you have the cloud token, you can get the connect key. You press the green button, and that will give you a shorter key, and this key is then punched into your mobile devices. It could be either your own or your customers, or etc. And that means you can then share this code over the internet. As long as you have an internet connection, you can be pretty much anywhere. And then we have the next tab. I skipped the Getting Started tab. It's a long description of pretty much what I'm saying here. And this is the Examples tab. It's a extensive list of different template apps that would allow you to connect to either generic devices of a sort or specific ones for a number of hardware, a number of brands, and they all carry the characteristics that they're fairly well documented, and they're meant as starting points. So when you find an example you like, you press copy, and it will then show up inside this tab, which is My Apps, and this is where the links to everything all the projects you have are here, and you can add them by just drag dropping the index HTML file, and you can also remove them here. And removing something from the list here doesn't remove your actual files. This is just a point to the file. So these are the three examples: the Hexiwear sensor one, there's a Hexiwear accelerometer, and the sensor one is interesting because it's a kitchen sink one that will take all the sensor values that are available and print them. So it will also be a good list for you. If you have a special sensor you're interested in, you can wedge that one out. The accelerometer is just using the motion service and the accelerometer. And then there's a last version of it, which is actually built in ECMAScript 6. So it's the new version of JavaScript. There's not that many devices out there that support ECMAScript 6, but it's an interesting experiment. And what you can do there is you can also use it with older devices, because there's a function built inside of Evothings Studio which downgrades JavaScript to older JavaScript. For instance, iOS devices, they don't understand ES6 just yet, but hopefully we'll see that happen. So what's left for me here is a walkthrough of some of these, and I've tried not to make long code lists, but rather show some of the highlights and to explain a bit how it's set up. And as I explained earlier, there's in these projects there's an index.html file, which is much similar to a web page, and then there's an app.js, and they have a certain interplay. So many of the elements are defined in this index.html, and then they're acted upon and called, etc., and filled with values in the app.js. So what we see here pretty much is very similar to a web page, that we have this is the body part of the HTML. So we see the disconnect button. We see there's on the very top there's a logo type. There's in this case it's the Evo logo. You can put your own logo there, of course, and then there's a back button, and those two live inside an element called header, and so they're placed up on top using CSS. And then you have the button to in this case it auto connects, so you need to disconnect the device, and then there's just elements. So every element has an ID. For instance, you have a battery. It says there's a inside the first paragraph there's a battery, and it has a small span with the ID with battery. So this element will get content from the callback from the battery function, etc. So this pretty much it's very straightforward, and it's easy to also to change this code any way you like. So this is pretty much the working part of the index HTML. And the app.js is in different parts. First, we have a app container that we use, and this is to avoid if you have your own UI libraries or something you want to include in this project, everything that's part of the functionality here is inside an object called app. So it lessens the risk of namespace issues. And then you have all the services, and as you can see, the end of the services are the same, and the beginning of the services are kind of running numbers from 18 and going upwards, and you can see every service has a unique ID. So by calling them, you can get data out. So first you have the connect button here, and the first thing it does, it stops if EasyBLE, if the BLE plugin is scanning, it will stop that and refresh the scanning. And then if the app is a Hexiwear device, in this case it's the device.name. If it's Hexiwear, then the app will connect to the device. This is if you have an environment with many BLE devices, you want to connect exactly with the right one. And then, of course, if there's an error, you can get a report. So this is the first action point when you press the connect button, and then it actually does the connection. And inside the connection, what it does, it reads services, and then it starts a notification for the services that you want to have running continuously. And there's also different kind of errors coming out if you were unable to read the services or unable to connect. And basically, the Hexiwear has different modes. Either it's idling, or it's acting as a sensor tag, motion gyro, pedometer, and you get from the Hexiwear you get different sets of data out. So, for instance, sensor tag is a good mode to get the information out. So you can check that it's running in the correct mode, or otherwise you can say this mode is not appropriate or unknown, or etc. Then we have two functions for reading characteristics, and this entire code, the entire app.js, it's less than 200 lines. So this is a very compact way of getting a lot of functionality out, and it's quite readable, hopefully, and we try to use proper function and variable names to make it easy to understand and be able to change this code in real time. And either here we can read the characteristics, which means you read the data once and then you have to repeat, or you can enable notifications, which will allow you to get this data continuously. And here's how it's done for the battery service. You enable notification, you have the battery service, you get the characteristics out that you define in the beginning, or you can read it only once. And then the last little function on this page is actually an interesting one, because this is the connection between the BLE part and the actual web page. Because the web page, of course, you have these element IDs, and we've chosen wisely to have the same IDs for the elements in the web page as these handles for the characteristics for battery, for instance. So if you have a characteristic battery or a service battery, then you can have an ID, which is also battery. So the last line says the element ID, the inner HTML, the content of that HTML element will get the content of this string coming out from the characteristics. So that's the whole magic really on getting this to work. Then we have the second example. This is also the last example. and a lot of the parts are the same. The big difference is really that on the end of this index HTML, I have a canvas ID. That's where we're supposed to be drawing the accelerometer data. Otherwise, and so it's very similar to the other example. We've also in the app.js, now I'm still with the accelerometer example here, I've added an array where you can store the acceleration samples, because you need to store the samples more often than you can draw them to get a good flow. And you also don't need to define all the services, but only the motion service and the motion accelerometer to get it to happen. And this last part is the actually drawing the function where we draw on the diagram. We take the motion accelerometer, we take the value, we do some conversions to get it in good scale, and we draw it on the diagram. And then there's a sub-function which does the actual canvas drawing. That's pretty much it. And this is also about 200 lines of code, this example. So I'm getting towards the end here of my presentation. So what to do next? Well, my hope is, of course, that you'll try this out, take it for a spin. We've been put quite some hours into getting all this up and running and getting this look and feel that a web developer would feel comfortable, even when targeting mobile devices. This is also, of course, in the handout, so you don't need to jot this down. The link is to an article on Hackster with many of these links and some of the highlights. And I'd also like to remind you of the competition going on Hackster for Hexiwear, which still has some ways to go. You still have some weeks left, and there's a lot of nice prizes and things there for you. So with that, I'd like to say thank you very much for listening this long, and I'd like to leave the floor back, and we can see if there's any questions at this point.
Thank you so much, Alex. You do have a couple of questions, so let's get started. So how much is the Evothings, and where can we start working with it?
That was the nicest question. I wonder who I paid to. No, I'm just kidding. The thing is that Evothings Studio is available for free, as in free speech. And what we do for a living to keep alive is that we've added several other functions that we think are important for professional users, like advanced debugging, the possibility to see what's going on the mobile devices while they're running a specific application, etc. So it starts out for free. You can connect 2 devices. If you buy an indie subscription, it's $19. That's like a couple of beers. That will give you 5 devices, but and for corporations, we also have other deals where we do more support. We can help do the first version of a piece of software, and then we'll hand it over, and you can continue tinker, etc. But it's important for us to have it open and available for free, and also for the academia, so that people are already paying for Apple accounts, Google accounts, etc. So we want to have something that will work out of the box right away and without cost or strings attached or credit cards.
Great. So next question. Can I get my data from the Evothings app to the cloud for Hexiwear?
Yes, you can. And I just got this question yesterday. We've done a number of examples, for instance, for AWS, for Bluemix, and for some other cloud services, and we. But I think any reasonably skilled web person could already now go and take one of the AWS examples and take the Hexiwear example and mix them together. But We will do it in a couple of days or so, because that's the next example we want to do. So either wait or be brave and take 2 examples and mash them up.
Great. So do you have an Evothings viewer on Windows?
There is one. However, it's kind of, the shoemaker's shoes. That we have one. It's not up to date, and we've decided that the moment people are asking for it to a larger extent, we will look into it. We've also had some conversations with Microsoft with the subject, but as of now, the Bluetooth low energy port is not up to speed. There's many of the other functions in there are, but BLE has been an issue for Microsoft in the beginning, and so there's one. It's a lab product. Please email me. I'll send you whatever I have, but we're not pushing it officially at this time.
So along those lines, can Evothings work with Azure servers?
I'm sorry, with the
Microsoft Azure servers?
Yes, in the sense that if there's a JavaScript library or similar available today that can interplay with Azure, and they use a reasonable interface like a REST interface or SOAP or CoAP or MQTT or something like this, we can, because it's basically things running inside the web container, and for everything that you can do from web technologies, you can also do from Evothings Studio, because we're running whatever there is. We don't have any Azure examples at this time. We started off in another end, and we spent a lot of time with the IBMs and the Amazons, etc. So we're getting there.
Okay. Does the Evothings, or is the Evothings IDE like a replacement for KDS or Embed, or is it a mobile front-end IDE?
It's for making mobile front ends, first of all, and it's in the sense we don't have, for instance, a text editor, but it's more a structure where we have folders. There's one folder for every project you have, and we watch those folders. And if you change something, if you change a bitmap in Photoshop, or if you change a text file, or if you change a script, Evothings Workbench will see, aha, there's something new going on here. It pushes the difference between what's on the cloud and what's on your development environment on your desktop, so that the cloud version will always be fresh. But you can use actually any editor you like. KDE and Eclipse are maybe not so good for JavaScript, HTML. There are other ones that are more appropriate. I mean, it comes to high-level functions and code highlighting and things like that. So it's not a complete IDE in that way. We do have integration with something called Electron, and we're looking at integrating with VS Code and other frameworks. But for now, it's more open-ended than so. So you'll continue to use your favorite text editor or your graphic editor, and the folders where the web content shows up, those will be the ones pushed to the net. So basically, you can also take other web projects that you had from before, and you can use them inside of Evothings Studio as well. But it's not a complete IDE in that sense that it's self-contained. There's everything in there. There's no graphical drag and drop editor. So if you want one of those, you can basically add it and then take that index file that you have and pull it into the studio, and then this folder will be watched until you tell it not to.
Great. What is the latency of a sensor reading using the hybrid plugin approach?
It depends. I mean, we've seen when we're using, for instance, the Bosch XDK, which is kind of an industrial. It's another type of sensor. It does very, very fast readings. It reads like 1,200 times a second, etc. For a few things, and there is a small penalty between what goes on inside the web container and what goes on in the native part. So if you for instance read 1,000 times a second between a web object and a native part, I mean, if you do Angry Birds that way, you won't get the nice smooth action. So we try to do retrieval of data in the native part, and then on occasion read this as a bigger object into the web. So you can do it different ways. In terms of actual data, there's no specific that it's exactly 2 milliseconds. It is slower if you do it wrong. If you do the collection of data native and then present it inside the web, because you don't need to present data 1,000 times a second. I mean, 50 times is quite enough. Then it's very similar. And the reasons for this is that the web part is getting so much hardware acceleration nowadays. In the iOS terminal, for instance, on iOS devices, there's something called Nitro, which is a JavaScript web GL acceleration in hardware, and it makes actually sometimes web code is faster than if you would write it in C or in Objective-C. So there's no definitive answer, but if you do it wrong, you get a lot of data latency. So it depends a lot on the application, but you can test with some of the examples we have, and for these kinds of applications like the IoT type apps, we see it works very well in both collecting and visualizing data.
Another question, Alex. Is Evothings based on the default firmware of Hexiwear?
We're actually we're not at this. We're not doing anything on the Hexiwear as such. So the only thing we depend on is the UUID of the services and that they are correct. So, and this is. I'm not saying this about Microelectronica or NXP, but in the past we've seen a lot of hardware companies that they suddenly change something. Oh, by the way, and because they're not used to working so closely with software companies and third parties, they haven't had the reason or the tradition to give the heads up before this happens. So suddenly, boop, and everything is changed. The good thing is that almost all of our specifics for each hardware is written in JavaScript, so it's very easy to cope with things, because otherwise if it was written native, we would need to change the native code, we would need to put it on the App Store, wait 5 days or 2 days, and then have a new client, etc. And then people with old hardware, oh, it's not working anymore, or so instead of having to write, you know, tens of SKUs of different mobile clients, we have one single mobile client, and then we have software on top. So we actually had an issue with the company where we, during the presentation, they told us, by the way, we changed the firmware. And go, oh, that's bad. But during the same meeting, we had this a guy sitting in the corner, one of our tech heroes, and he actually changed the code to work with new firmware while we were still in session. So we don't rely as much on the specifics of each firmware, but it's good to know, and I'm happy every time they don't the names of things are not changed.
So we have a question regarding pricing. How does it work for distribution in app stores?
For us, we only monitor the uses of the development tools. So for instance, if it says you can only connect 5 devices, it means devices during development. So when you're happy and your code your app does what you want, it's your code, and then this code you take you use Apple and Google's tools and you put it on the App Store. So we have no say in what you do with your code, and not even what you do with our code, because we released this as Apache 2. So we're only concerned about usage during development and the amount of clients. So once your app is finished, because this Evothings viewer, it's not the runtime environment where your code will run forever. It's more that when your code is finished, you will compile and make your own app, which is not dependent on Evothings viewer or any other app. It's a standalone app. It's just that it's created in a different way. It's created using this hybrid process, and it's your code, and you can do what you like with it, really. So we don't police what's going on the app stores, or if you're successful, or if you have 100,000 users, or etc. We chose another path and another business model.
So I have a long question for you. Presumably the HTML and JavaScript can reside on the phone and run without a GSM connection. How do you manage updates from the server? Does this come only from your server or our own server?
That's an excellent question. The code, because the Evothings viewer, for instance, it's a web browser. You can punch in any URL you like. You can also fetch code from anywhere you like. During the development, we have a limitation that we use HTTPS because the industry has asked for an end-to-end security. And one of the things is that also during development, it should be impossible for a third party to see the code in clear text. So the other server, if you want to put your code on another server and have some code from us, some code from another server, they both need to be HTTPS. But if you set up a system where you point your software to a server of your own or a server in the cloud somewhere and don't use Evothings at all, that's completely fine. We have the mirror we use is a service to have easy development. It doesn't affect how the app is acting later. I mean, if you're, for instance, reading data off the Hexiwear device and then you're sending it to a cloud, you don't need to, you're not using our service. It's not going via us, and we're not tunneling or proxying or anything. But rather, we welcome that you combine them, because we have a lot of things on board. We're now putting up our own messaging backend. But if you like your own messaging backend better, if you use Bluemix, for instance, or some other messaging, that's completely fine too. So basically, if there's something that you can do client-side and use the persistence of the web container, the web store, etc., and then push data to any cloud of your choice, that'll work just as fine as any web project out there. Long answer.
Okay, so we are almost out of time. So finally, I want to ask you a question from me. How does the maker community benefit from Hexiwear and Evothings?
Well, I have a lot of makers around me, like in the place where our office is. In the cellar, we have Stockholm Makerspace, and they have seen the device, and they think several things are great with it. First of all, it's a nice form factor, because many of those devices they don't look as nice, and often you can't extend these sensor devices, and I think the Hexiwear with this adapter and the possibility of adding other sensors to it. I think there's 200 plus different sensors. It's very good. I mean, the possibility of adding things is improving a lot. Also, we're very fond of the little screen because you can actually see that there's something going on. That's quite unusual. And then I think there's more sensors on the Hexiwear than we've seen almost on any other device. So these things together makes it very good for both tinkering and experimenting. And myself, I have a mechanical engineering background, so it's quite close. I mean, it's close at hand to look at the form factor and how things are used in practice. And I think it's a bit big for a watch, but having it on your wrist and imagining it that in production it has a different form factor. Right now it does exactly what it's supposed to, and you can get an end-to-end system working quickly. I think it's a new generation of devices coming out now. And I think Hexiwear is a good example of that. And I like also that you can program it in embed, because that allows you to do a lot of nice things. For instance, embed has a cloud service, so you can have your text editor and a web browser, and then all the building on the embedded side takes place in the cloud, and then you can over-the-air update the Hexiwear over the phone. You don't need the cables. You don't need even to bring your computer. We've done some of those exercises, and it's very promising the way things are going. So easy from idea to finished product, I'd say.
Okay, that's all the time we have. Thank you so much, Alex, for presenting this.
My pleasure. Thank you very much.
Thank you.